So we will now discuss problem number 14. It says calculate the cell EMF and delta G for the cell reaction at 25 degrees Celsius. So the cell is given zinc solid and then zinc sulfate zinc 2 plus, concentration is given 0.0004 molar, and then cadmium 2, the concentration is cadmium 2 plus, concentration is 0.2 molar, and cadmium solid, and E naught values are given for E naught value for zinc 2 plus Zn is minus 0.763 volt, and E naught for cadmium 2 plus 2 cadmium is minus 0.403 volt. So first we will start with we will calculate cell EMF, and from there we can calculate delta G by using equation minus NFE. So in order to calculate delta G, we need to calculate cell EMF. Okay, so first we will write the half cell reactions. So at anode, oxidation takes place. So Zn goes to Zn2 plus aqueous plus 2 electron, and the corresponding E naught value for Zn2 plus Zn is minus 0.763 volt, and at cathode reduction takes place. So Cd2 plus aqueous goes to Cd solid minus 2 electron, and E naught value is also given here. E naught Zn Cd2 plus Cd is minus 0.403 volt. So the overall cell reaction we can write Zn plus Cd2 plus aqueous gives Zn2 plus aqueous plus Cd S, right, solid. Okay, so we got the overall cell reaction. Now we know the E naught cell. So E naught cell will be E naught cathode. So E naught cathode minus E naught anode. So E naught cathode is minus 0.403 volt, and E naught cathode anode is minus 0.763 volt. So minus 0.763. So this is the volt. So if we calculate this one, we get E naught cell is 0.36 volt. This is E naught cell. Once we got the E naught cell, we can calculate E cell by using Nernst equation. So from Nernst equation, at 25 degrees Celsius, we write E cell is E naught cell minus 0.06 by N. N is here, so N is 2 here. So 2 and then log. So concentration of Zn2 plus by concentration of Cd2 plus, right. So now we substitute the values. So E naught cell is 0.36 minus this will give 0.03, log concentration of Zn2 plus is 0.0004 and concentration of Cd is 0.2. So this is the E cell value. So E cell will be, if we calculate this one, so we get 0.36 minus 0.03, and log of this value will give you minus 2.7. So if we calculate this one, we get E cell is approximately 0.44 volt. So this is the value of E cell. So once we get the E cell value of E cell, we can easily calculate delta G. Okay. So therefore, for the cell reaction, delta G is minus NFE, okay, or E cell here you can write. Okay. Now N is 2, so minus 2, value of F we know 96,500, right, and 0.44. So this is given in coulomb and this is given in volt. So overall we will get coulomb volt means joule. Okay. So we get 84,020 coulomb times volt means joule. So 84,020 joules. So if we convert it into kilojoule, we get 84.02 kilojoule. So this is the value of delta G for this cell. This is very standard problem, but very important problem. Okay. So we can calculate delta G by using Nernst equation. Next we move to problem number 15. It says for the cell Mg to Mg2 plus aqueous and Ag plus to Ag, calculate the equilibrium constant at 25 degrees Celsius and also the maximum work that can be obtained by operating the cell. So E naught values of Mg2 plus Mg and E naught value of Ag plus Ag are given. So E naught value of Mg2 plus Mg is minus 2.37 volt and E naught value of Ag plus Ag is 0.8 volt. So again we will write the half cell reaction. Okay. So considering the half cell reaction, so at anode, so oxidation takes place at anode. So Mg solid goes to Mg2 plus 2 electrons, and at cathode reduction takes place. So Ag plus, so this is aqueous here. So Ag plus aqueous plus 2 plus electron, 1 electron here, so gives Ag solid. Okay. So if you multiply this equation by 2, so the overall cell reaction will be Mg solid plus 2 Ag plus aqueous gives Mg2 plus aqueous plus Ag solid, right. So this is the overall cell reactions. Now E naught values are given, so we can calculate E naught cell. Okay. So E naught cell will be E naught cathode minus E naught anode. So E naught cathode is minus E naught cathode is 0.8 volt, and E naught anode is minus 2.37. So minus of minus 2.37. So if you calculate, you get 3.17 volt. So this is the value of E naught we got. Okay. Now once we got the value of E naught, we can easily calculate log Kc. Okay. So, we know again E naught cell is 0.06 by n log Kc at 298 K temperature. Here Kc is where Kc is the equilibrium constant. Now, we substitute the value of E naught. So, we get 3.17 equals to 0.06, and here number of electrons n is 2 and n is 2 electrons are being utilized here. So, by 2 then the log Kc. So, we get log Kc is 2 times 3.17 by 0.06. Now, we can calculate the equilibrium constant value Kc. So, Kc will be 2.86 times 10 to the 107. And the second part is the maximum work. So, maximum work is nothing but your delta G naught here. Okay. So, the maximum work that can be obtained nothing but delta G naught here is minus N F E naught cell. So, minus N is 2, F is 96,500 coulombs, and E naught cell we already calculated. E naught cell is 3.17 volt. So, we get delta G naught is 6 minus 611,800 coulomb volt, means minus 611,800 joules. Coulomb times volt gives joules. So, we get delta G naught is minus 611.8 kilojoule. Okay. We convert it into kilojoule. So, this is the value of the maximum work done, and this is the value of equilibrium constant Kc. Next, we move to problem number 16. It says for the cell reaction Sn plus Pb2 plus goes to Sn2 plus Pb solid. So, E naught values are given. E naught Sn2 plus to Sn gives is minus 0.140 volt, and E naught Pb2 plus to Pb is minus 0.126 volt. So, calculate the ratio of concentration of Pb2 plus to Sn2 plus ion at which the cell reaction be reversed. Okay. So, first we need to find out what is the value of E naught cell. For that, we need to understand the reaction taking place at anode and at cathode. Okay. So, at anode oxidation takes place, right. So, at anode oxidation takes place means this is the overall cell reaction. So, in anode Sn solid goes to Sn2 plus aqueous. This is the oxidation here, right, plus 2 electrons, and corresponding E naught value is minus 0.140 volt, and at cathode reduction takes place. So, here Pb2 plus aqueous plus 2E gives Pb solid, and the E naught value of this is Pb2 plus 2 Pb is minus 0.126 volt. Okay. So this is the, then we get the overall cell reaction like given in before in above. So the overall cell reaction is nothing but what is given in the question. Okay, so SN solid plus Pb2 plus aqueous gives SN2 plus aqueous plus Pb solid, and E naught cell will be E naught cathode minus E naught anode. So E naught cathode is for lead. So we need to write this one minus 0.126 minus E naught anode is minus 0.140. So this is volt. So if we calculate this one, we get 0.014 volt. Now E cell is, so from Nernst equation, at 298 K temperature, we write E cell is E naught cell minus 0.06 by N log. So overall cell reaction is this one. So products is SN2 plus. So concentration of SN2 plus by concentration of Pb2 plus. And here N is 2, number of electrons involved is 2. So we get E cell is E naught, the value of E naught cell is 0.014 minus 0.06 by 2 log concentration of SN2 plus by concentration of Pb2 plus. So we get 0.014 minus 0.03 log concentration of SN2 plus by concentration of Pb2 plus. Now at equilibrium, because we need to calculate the ratio of concentration of Pb2 plus to SN2 plus. So at equilibrium, E cell is 0, right? That we already discussed in the class. Okay, so E cell is 0. So we write at equilibrium zero from here. Actually we write 0 is 0.014 minus 0.03 log concentration of SN2 plus by concentration of Pb2 plus. So if we further simplify this one, we get log concentration of SN2 plus by concentration of Pb2 plus will be 0.014 by 0.03. So we get concentration of SN2 plus, or if we take now, because we need to calculate ratio of Pb2. So we need to calculate, basically we need to calculate ratio of concentration of Pb2 plus by concentration of SN2 plus. So we take minus sign. So minus, if we take the minus sign, we get log Pb2 plus by SN2 plus will be minus of 0.014 by 0.03. So, we get concentration of Pb2 plus by concentration of Sn2 plus is 0.336. So, this is at equilibrium, right? At equilibrium we get this one, but we need to calculate the ratio of concentration of Pb2 plus to Sn2 plus, at which cell reaction will be reversed, right? Thus we can write, thus the cell reaction will occur till concentration of Pb2 plus by concentration of Sn2 plus equals to 0.336, right, or less than 0.336. Till that, once it reaches 0.336, then the equilibrium will reach. Okay. So E cell will be negative and the reaction will be reversed. Right. So this is the minimum concentration ratio of Pb2 plus and Sn2 plus. Next we move to problem number 17. It says, consider an electrochemical cell A solid goes to An plus aqueous 2m, then B2 plus aqueous 1 molar to Bs. The value of delta H for the cell reaction is twice that of delta G naught at 300 K. Calculate delta S naught in joule per calorie per mole. So, delta S will be not per mole, only joules per Kelvin of the cell per mole of B formed at 300 K if the EMF of the cell is 0. Okay. So, half cell reactions we can consider, okay, like before. The half cell reactions are at anode. So, A solid goes to An plus aqueous plus Ne, and at cathode reduction takes place, at anode oxidation takes place. So, B 2 plus, okay, this would be 2n here, not 2n. Huh? So, B 2n plus 2Ne gives B solid. Okay, so we need to multiply this by 2, and then the overall cell reaction is the overall cell reaction is A solid plus B 2n plus aqueous gives An plus aqueous, 2 times An plus aqueous, and then we get 2A here, 2An plus aqueous plus B solid. This is the overall cell reaction. So, E cell will be E naught cell minus RT by NF ln concentration of An plus by square, okay, N square by concentration of B 2n plus. Okay, so we get E cell is E naught cell Now the concentrations are given, so RT by NF. Now N is here 2N, okay. So here N is nothing but 2N, so we write 2N F here, ln concentration of An plus is 2m, so 2 square by 1 square, 1, right. So we get this. So at EM of the cell is 0, so when the EMF of the cell is 0, we write E cell equals to 0. So we get, from here we get E naught cell is RT by 2NF ln 4, right. Now delta G naught, we know delta G naught is delta H naught minus T delta S naught, right, that we know, right. So again delta G naught is minus NF E naught, so we write N is 2NF, and the value of E naught is RT by 2NF ln 4, right. So we get minus RT ln 4. So this is the value of delta G naught. Now it said that delta H naught will be twice that of delta G naught, okay. Therefore delta H naught is minus twice RT ln 4. So we got delta G naught, we got delta H naught, we will put it, we put these values here, okay. So we write minus RT ln 4 is minus twice RT minus T delta S naught. All right, so we get twice RT ln 4, ln 4 is also there. So delta H naught is minus 2 RT ln 4 minus T delta S naught. Okay, so we get minus okay, T delta S naught. We are taking this on this side, we get minus RT ln 4. So we get delta S naught is minus R ln 4, and value of R we know, delta S value of R is minus 8.314 times ln 4. The value of ln 4 is 1.386. Okay, so we get delta S naught is minus 11.525 joules per Kelvin per mole we are getting, but since it says per mole, okay, so we can actually omit this per mole, so we can write delta S naught is minus 11.525 joules. Next we move to problem number 18. It says estimate the potential difference needed to reduce Al2O3 at 500 degrees Celsius. The free energy change for the decomposition reaction 2 by 3 Al2O3 goes to 4 by 3 Al plus O2 is delta G equals to 960 kilojoule. Okay. So Al2O3 this is nothing but twice Al3 plus 3 by 2 O2 minus, right? We can write this Al2O3. So when it decomposes, it gives 2Al plus 3 by 2 O2, right? Okay, so here we calculate here N is 6, right? Because 2Al3 plus goes to 2Al after 2Al3 plus 6C gives 2Al, right, and for 3 by 2 O2 minus goes to 3 by 2 O2, okay, right. So, you get 3 by 2 E. So overall we get 6 electron is being transferred here, okay. So, N is 6. So, for the decomposition reaction, so this is the general expression, but we have the decomposition reaction of for this one we need to consider. So, for the decomposition reaction, two by 3 Al2O3 goes to 4 by 3 Al plus O2. N will be, so when 1 mole, for 1 mole Al2O3 N was 6, right, for 2 by 3 Al2O3, so N will be 2 by 3 times 6, right. So, we get 4. So, 4 electrons are being involved here, okay. So, N is 4 here. So, delta G is minus NFE. So, we need to calculate E, okay. So, delta G value is given. So, delta G is 960 kilojoules. So, we need to convert it into joule times 10 to the 3 joules, and N is minus 4 here, right, and F is 96,500 coulomb and E, okay. So, E is 960 times 10 to the 3 by, you have the minus sign here, and then this is in joules by 4 times 96,500, it is in coulomb, okay. So, joules by coulomb gives volt. So, if we calculate this one, we get 2.487 volt, and we have the minus sign here. So, therefore, potential difference needed, the minimum potential difference needed to reduce Al2O3 is 2.487 volt.